Okay, once again, good morning. Today we'll start with the first module. So in the first module, we are going to learn about the DC circuits. In DC circuits, let us start with the syllabus starts with the Ohm's law and the Kirchhoff's law. We will start with the basics of the electrical circuit. Like we'll try to understand the different components of the electrical circuit, like what is the electric current, what is potential, electric potential, what is potential difference, what is EMF, what is power, what is energy. Those are the different components. And then we'll start with the Ohm's law. Okay. Then we'll understand the Ohm's law. We will solve problems on the Ohm's law, and then we will look into the Kirchhoff's law. uh, Basically, these laws are provided so that we can do the circuit analysis. And what is circuit analysis? Whenever electrical circuit is given, we need to do the analysis in order to find the what is the current, what is the voltage, how much is the power, and how much is the energy consumed. Although those are the part of the analysis. In order to do those things, we will be utilizing the Ohm's law and the Kirchhoff laws. And then we'll study about the analysis of the series, parallel, and series parallel circuits. And as I told you, in case of a DC circuit, there is only one kind of a load, that is resistor. And we will understand if resistors are connected in series, what is the behavior. If they are connected in parallel, what is the behavior. If we connect them in a series and parallel combination, what is the behavior. All those things we are going to study. And we are going to study about the power and the energy. And as second part of the module 1, we'll understand the AC fundamentals, how the sinusoidal voltage is generated, what is the concept behind it, what is the frequency of the generated voltage, because it is a sinusoidal waveform. Whenever we have sinusoidal waveform, there are some parameters associated with that particular waveform, like peak of that sinusoidal value, that is a peak value or the maximum value, then frequency, what is the period of that particular waveform. Those things we are going to study. Then definition and numerical average values and root mean square value. What is the average value of the sinusoidal quantities, voltage or current? They are represented in two forms. One is the average value, and second one is the RMS value or the root mean square value. So we will see how the average value is calculated and how the RMS value is calculated. Then based on the roots, average value and the RMS value, we have two factors, form factor and peak factor. Okay. And we are going to study about the phasor representation. The phasor representation, one way of representing alternating quantities is the waveforms, and another way is the phasor representation. This phasor representation is a very useful when we are like adding voltages, adding current. So phasor representation, with phasor representation, it would be very easy. So I request all the late joiners, please join on time. It creates a disturbance. Okay. Then we will see the phasor representation. So let us start with a very simple DC circuit. This is a circuit. What is a circuit? A DC circuit is nothing but it is the a closed path provided so that the electrical current can flow, and it is supplied with a EMF source. Okay. EMF is electromotive force. You can either call it as a EMF or voltage source. That is the active source of the circuit. What is the active source of the circuit? The active source is the one which provides power to the circuit, means which provides the, it is a source of the particular circuit. It provides the power to the circuit. Those are called as the active components, or the, you can call it as a source. And This is the resistor. It is called also called as a passive element, or it can be also called as a sink. What is a passive element? Passive element is the one which consume power. Active elements, they give power to the circuit, and the passive elements, they consume the power, means they take the power. And this is the closed path. And you have to remember, in order for the current to flow, okay, whether it is a DC current or the AC current, in order for the current to flow, there should be a closed path, means there cannot be any disconnects. If there is any disconnect, if there is any open breakage in the path, then the current will not flow. So it should be a closed path. This is the resistor, this is the voltage source, and these wires represents the conducting wires. So you can assume that these wires will not have any kind of a resistance. They are used for the making connections. So you can see one wire on this side and another wire on this side. When we connect a voltage source to a resistor, the current will start flowing from the positive terminal through the resistor, and it will come back to the negative terminal of the voltage source. This is the conventional direction of the current. The direction of the flow of the electrons is opposite to the conventional. That is, the electrons will flow from the uh, negative terminal through the resistor and back to the positive terminal. For henceforth, for all our analysis, we are going to consider the conventional flow of electric current. That is, current will flow from the positive plate through the load or the resistor, and it will come back to the negative terminal. And when we are representing all these quantities, whether it is a voltage or a current or any other parameters, the usual convention that is used is for all the DC circuits. Okay, for DC elements we use the uppercase letters. For example, you can see current is represented as capital I, and EMF as capital E or capital V. And in case of a AC, these are represented with a lowercase. That we will see when we get into the AC fundamental. And resistor is connected between point A and B. The voltage across the point A and B is called the potential difference across the resistor, or you can just the voltage across the resistor V. When we are using the different terminology, the electromotive force EMF, voltage, voltage difference, electric potential, for all practical purposes, you can think those are similar entities, or they are synonymous. Okay, as we discussed, a closed path followed by a DC current is called as a DC circuit. Direct current starts from positive terminal of a voltage and flows to negative terminal via the load. Load is nothing but the resistor. And load for DC circuits is always resistance. One thing you have to remember, when we are dealing with a DC circuit, the only kind of a load is a resistor. So there is no other kind of a loads in case of a DC circuits. What is a load is, general meaning is the one which consumes power. When we connect to the a circuit, that is called as a load. Load is a general term. Okay, for another example, like in your household, you have a fan, you have a refrigerator, you have a washing machine. Those are all loads on the circuit. Okay, so what kind of a load? In it is a either resistive load. If it is a AC, there could be a inductive load, or there could be a capacitive load. In case of a DC circuit, we have only one kind of a load, that is a resistive load. Active elements are sources, are the elements of a circuit which possesses energy and it imparts energy to the circuit, like the voltage source or the current source. So active elements are the sources are the one which gives energy to the circuits, and opposite to that, passive elements or the sinks, they consume the energy, electrical energy, consumes or dissipates the electrical energy. First, we will understand the what is the electric current. Can anybody tell what is electric current? What is electric current?
Flow of charges.
Very good. Okay. Flow of electric charges or flow of electrons. It is a flow. For example, is a water current. Okay. If you see the a stream, we call it as a water current. What is the water current? Water current is nothing but a flow of water particles. Similar to that, the flow of free electrons or electric charges in a closed path, it is known as a electric current, and electric current is represented by capital I. And what is the unit of electric current?
Ampere.
Ampere. Very good. So electric current is represented as a ampere. So this is a simple circuit here. You can see a copper strip is connected to an voltage source, and there is a flow of electrons. So the flow of electrons is from negative plate to the positive plate of the voltage source. For all our analysis purpose, we will take the only conventional direction of the current, that is current flows from the positive plate to the negative plate. And what is the strength of electric current? So same example, water current, right? If
Flow of
yeah,
electrons.
yes, please. What is the strength of the current?
Rate
Electric.
of electric charges.
Yeah, correct. That is correct. So same if you take the water example of a water current. Suppose if you see a water flowing, okay, like in a pipe or something like that, if the rate of flow is slow, means it is flowing very slowly, means per second, if you consider the amount of water that is passing, is the measure which is taken as the strength. So if the water strength of the water current is more, then the amount of water flowing per unit of time or per second, the amount is more. Similar to that, if more electrons are passing per unit time, then we say the electric current is more. For example, we say the current is 5 amperes, current is 10 amperes, current is 50 amperes. When you say current is 50 amperes, that is the amount of electrons that are flowing per unit time is much higher. So that is how we represent. So strength of electric current is nothing but it is the rate of flow of the electrons or the charges in a conductor. So when we say the strength of electric current is the rate of flow of electric charge, whenever we have used the rate word, that time factor will come. That is how we represent the current. I is equal to capital Q divided by T. And what is capital Q? Capital Q is the nothing but the total electric charge or the total electrons that are flowing per given time, that is Q by T. So the current is represented in using the ampere unit, or also you can represent it using the coulombs per second. That is the units that we use to represent the current. And what is the total electric charge? Total electric charge is nothing but N into E. What is N into E? E represents E represents the a charge on single electron, okay, and N represents the number of electrons that are flowing. So the total charge is number of electrons into the charge on each electron. What is the charge on each electron? That is represented, this is a constant, right? It is constant, and it is given by E is equal to 1.6 into 10 raised to minus 19 coulomb. So current can be represented I is equal to Q by T, or it can be represented, Q is represented as N into E, where N is the number of electrons divided by T. So these are the different forms you should remember. In case in the exam they might give the either electric charge, total charge they might give, or they might give number of electrons flowing. If they give the number of electrons flowing, you should remember what is the value of the E, that is the charge on single electron, that is 1.6 into 10 raised to minus 19 coulomb. Next element that we are going to understand is electric potential. Electric potential is represented as V or E. So first of all, what is the meaning of potential? Anybody? English meaning. Okay. In general, what we understand by the potential?
Different energy.
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 Okay. Anybody else?
Strength.
Stored energy.
Strength.
Strength.
Capacity.
Storage
Capacity.
capacity.
Capacity, very good. Capacity. See here a little bit. I know everybody. You have the understanding. You gave different words, but you have the understanding of the potential. So here we have to be like a technically correct. So capacity is the one we can consider. So capacity to do something, right? It is called as a potential. The meaning of that. So here, before going into electric potential, we will go with a simple example of this. Uh, these two are similar tanks, and they are filled completely to the full limit, full level. Both tanks are filled. Okay. The only difference between them is the height, isn't it? So the water which is in this tank and water in this tank, the quantity is exactly same. The what is the difference is in the height. So what would be the potential of this water, and what would be the potential, whether potential of, if I call it as A and if I call it as B, which water will have more potential?
A.
A,
Yes, sir.
right? Very good. The reason being, the height is more, the potential is more, right? Potential energy is more. And why the potential is more here for water tank A? Anybody? Because
Increase
the
in height.
height, increase in the height, that is one thing. What is the other factor?
Gravity.
Gravity, yes.
Mass.
No, not mass. Okay, if I ask you a question, if I ask you to fill these two tanks, okay, to fill these two tanks, which one will need more work to be done?
A. A.
Right,
A.
exactly.
A.
Right. See the amount of work you have done. Okay, the amount of work you have done to fill this particular tank is much more compared to this one. So the amount, when the amount of work done is more, so because the height is more, amount of work is done more. That is the reason the potential is more. That is the reason this particular tank A, this water, if you use it to run some turbine, right? Everybody understand what is a turbine? A turbine is like in hydroelectric plant. They, what they do is they use the water jets, they put it on the turbines. So turbine is a structure where when you put the water, when water falls on that turbine blades, the it will start rotating. That is how in hydro, not only for hydroelectric power plant, other power plant, they use the steam or water jets to rotate the blades. Okay, rotate the turbine. When turbine starts rotating, it is coupled to generator. And what is a generator? Generator is the one which converts mechanical energy into electrical energy. So if I connect this to the turbine, this has a more potential. It will rotate the turbine faster compared to this one. Isn't it? Okay, so amount of work done is more, the capacity of this particular, Raghavendra, please join on time. Okay, the class started at 9:45. Okay, again, once again, please, it's an interruption. Please join 2 minutes before, all of you. So the capacity of this water to do work is more compared to this one. So that capacity to do work is called as a potential. Now On similar lines, now what is electric potential? Okay, so we will go with the, now you have the understanding with respect to that water tank. Now we will see what is electric potential. What is electric potential? Work needs to be done to charge any body, right? So in case of a water tank, Mayur, you have to join on time. Okay, work needs to be done to charge any body. So you are doing work to fill the tank, isn't it? In case of electricity, you are doing work to charge some body. To charge that body, work needs to be done. This work done is stored as a potential energy in the body. When you fill that water in the tank, the water was stored and it was stored as a potential energy. Similar to that, you are doing work to charge a body, and whatever the work you have done to charge that particular body, that is stored, that particular work is stored as a potential energy in that particular body. The capacity of the charged body to do work is called as a electric potential. What is electric potential? The capacity of the charged body to do work. Where it will do the work? It will do the work in the electric circuit. Okay, the capacity of the charged body to do work in the electrical circuit is called as its electric potential. Okay, everybody understood? Anybody has question? Okay, so that is the so you remember electric potential means what? Capacity to do work. Okay, you can explore all this. Okay, one keyword you can remember is electric potential is the capacity to do work. Okay, when body will be has a capacity to do work when it is charged. And what you do to charge the particular electrical body, you do the work. So electric potential, V is equal to work divided by work done divided by charge, that is W by Q, and work done is represented in the unit of joule. Joule per coulomb is equal to 1 volt. So we represent the electrical potential as joule per coulomb, or simply we call it as a volt. Electric potential, voltage, voltage difference, EMF, you can take it as synonymously, and all of these quantities are represented in the unit of volt. A body is said to have an electric potential of 1 volt if 1 joule of work is done to give it a charge of 1 coulomb. That is how you get 1 volt, 10 volt, 15 volt, 20 volt. The amount of work done is more. So they 20 volt, the amount of work done is more. It has a more capacity to do the work in a particular electrical circuit. Now we understood what is a potential, right? Potential is what? Potential is the capacity to do work. Now we will understand what is a potential difference. It is also called as PD or V or E. I told you these things are used synonymously. There is a very slight difference, but you can, for all purposes, you can think they are similar. Okay, so potential difference. Before we understand electric potential difference, these are the two tanks. Just think they are connected by a pipe, a hollow pipe, and in between I have a valve. The water levels are different here. If I open this valve, what will, and let us say this is tank A, this is tank B. If I open this valve, what will happen?
Water will flow from B to A.
Correct, B to A. How long it will flow?
Till it comes equilibrium.
Till both reaches the same level, isn't it?
Yes, sir.
That is correct. So now assume that now initially this water tank B has this much level, this uh, particular valve is closed, and this is the level. Now this particular tank has a water. Okay, if you compare from this level, this has a column of water which is more than this particular. So that has a higher potential compared to this one. because of its height, it has a higher potential. The minute you open the valve, because it is at a higher potential, the water will start flowing from tank B to tank A, because there is a difference in the potential. The tank B is at a higher potential and tank A is at a lower potential. So that is the reason from the water will start flowing from tank B to the tank A until the both levels are same. What is the meaning of both levels are same? Now both the tanks are at the same potential. Then you do not see any flow of the current. So flow of the water. The flow of the water is happens only when there is a difference in the potential. Everybody agreed? And the water will flow. The flow of water, what you can call water current. The water current will be there as long as there is a difference in the potential. The minute both tanks have the same level of the water, there is no water current. Water will stop flowing from one tank to the another tank. Similar to that, electric potential, you can see here, there is a one body, there is a one electric body. One second. Okay. So now we will understand the potential difference. So what is the potential difference? We have, this is the electric body B and electric body A. These are charged. Work is done and these bodies are charged. And electric body A is charged to plus 5 volt and electric body B is charged to plus 3 volt. So if you see here, the electric body A is at a higher potential and B is at a lower potential. If I connect these two bodies with a conductor, so if you say, if I connect these two bodies with a conductor, the electronic, the convention is like from positive to, it will start flowing from the electric charge will start flowing from the higher potential to the lower potential. That is the conventional direction. So how long it will flow? As long as these two reaches the same potential. What would be that potential? So this would become initially it would be 5 volt. When you connect, the charges will start flowing to the B until this becomes 4 volt. Okay, it will reduce from 5 to 4 volt and this will increase from 3 to 4 volt. That is when the current will stop flowing from the electric body A to the electric body B. So what is the potential difference? Potential difference is nothing but the difference between the charge of this body and the charge of this body. That is, if I call the potential of this body as VA and this is VB, what is potential difference? PD is equal to VA minus VB. That is 5 minus 3, that will come as a 2 volts. So what is the potential difference? Potential difference is a 2 volt. So current will flow as long as there is a potential difference. If you remember Wheatstone bridge experiment, where you balance the Wheatstone bridge, whenever you balance the Wheatstone bridge, what happens? We have a galvanometer in the central branch. The galvanometer will show the current as 0. What is the meaning? There is no flow of electricity in a balanced. Why there is no flow of electricity? Because the both the ends are at the same potential. When you make the Wheatstone bridge as a balanced bridge, the potential difference between these two becomes 0. That is why there is no current that will flow. The difference in potential between two charged bodies is called as a potential difference. Okay, this is how. When two bodies A and B are connected through a conductor, the current flows conventional from higher potential to lower potential until both body attains the same potential. That is the potential difference. So what is the potential difference? What is the unit of potential difference? Because it is VA minus VB, 5 minus 3, the volt. Volt is the same unit for the potential difference. Anybody has question? Okay. Next, electromotive force, EMF. What is the EMF, electromotive force? Electromotive force is nothing but it is the force which will make the current to flow in the circuit. What is the current? It is nothing but the electromotive force. It will make the electrons to flow in a particular circuit. That is a EMF source. It is a force which circulates or tends to circulate electric current in a closed circuit. You can see here, this is a closed circuit. We have resistor 1, resistor 2, and they are connected to EMF source. So either you can call it as a EMF source or the a voltage source. E, okay, and these are connected with the wires, this side and this side. Now we have resistor R1 and resistor R2. This is the node A, node B, and node C. We understood what is this. Either you can call it as a voltage, EMF, or potential. That is 5 volt. So this particular EMF source, it is the source which is work has been done, and it is has a potential of 5 volt, or you can call it as a EMF source. And it has a capacity to, it has a it makes the current to flow in that particular source circuit. It acts as a source. So current will start flowing. It will flow through the node A, R1, node B, R2, and C, and back to negative plate. So that is the EMF source. Now, what is the voltage difference or the potential difference for the resistor R1? So, what is the what is the voltage difference? Is the potential at point node A minus potential at node B. That is, if you say this is VA and this voltage is VB, the potential difference across resistor R1 is VA minus VB, or just you can say it as VAB. Similarly, the potential difference or the voltage across resistor R2 is VBC, because it is the potential difference between VB and VC. Okay, it is the difference between VB and VC. That is how in whenever you are see a circuit, if you are saying there is a current is flowing through the a resistor, the current will flow through this particular resistor only when there is a difference of potential. That means what? If current is flowing in this direction, VA, this potential is higher than this potential. So when VA is higher than VB, current will start flowing from the direction A to B. If the potential of B is higher than potential of A, the current will flow in the opposite direction. That is, it will flow from B to A. And what are the different sources of voltage, EMF sources? You must have seen the batteries, dry batteries, then alkaline batteries. Those are the different examples of the EMF sources. So potential difference is the same. So in every circuit, we may not call it as a potential difference. Just we will say sometimes voltage across resistor R1, voltage across resistor R2, which is nothing but the potential difference across R1 and potential difference across R2. What is a resistance?
The, the obstruction opposed to the flow of current.
Which opposed to flow of current.
Yes. Okay. So whenever you connect EMF source to different kind of materials, some materials they offer more resistance, and some material they offer less resistance. The property of the material, by virtue of it, which it opposes the flow of current is called as a resistance. So the opposition offered by a substance to the flow of electric current is called the resistance of a material. So every material has a different level of resistance. Some materials, they have a very high resistance. They will not allow the electrons to flow through their body, and some materials, they easily allow the electrons to flow through their body. So if the substance offers a very high resistance to the flow of the current, those are called as an insulator. And the example for the insulators are
Paper.
Rubber, rubber,
Plastic.
paper, rubber,
Stick.
wood,
wood, stick, okay,
Plastic.
plastic, glass, okay. Those are the ones which are very good insulators, means they offer very high resistance. They will not allow electrons to freely flow through their body. And certain substances, they offer very less resistance. Those are called as a conductors. And which are the examples of the conductor?
Iron,
Iron.
metal,
Which metal?
silver,
Metal.
aluminum,
Aluminum.
Copper, gold.
copper,
silver,
Copper.
bronze,
Gold,
Bronze.
silver.
Gold, silver, yes.
Water.
Water, very good.
Lead.
Okay. What is that?
Lead.
Lead.
human body,
Yes, human body. You know why human body is it's also a conductor, good conductor.
it contain more amount of water.
Yes, very good. Okay.
animal body, sir.
This information, this is there is a one module on electric shocks precautions. There we will understand, yeah, in detail what, how, why we should take a precaution. Okay, so that is correct. Very good examples of the conductors. And now, which one is better? Conductors are better or insulators are better?
Both
conductors,
are
Why both?
We need both.
in some case for precaution we need insulators,
Hmm.
and in circuits we need flow of current conductors.
Yes, yes. The answer is both are very, very important. How much is conductor is important? The same amount, the insulator is also important, because you, if you see your household, do you have any conductors without insulator? No. You have wires. On top of that, there is a coating of the plastic. You have refrigerator, on its body there is a coating. Washing machine, there is a coating of insulators, right? Without insulators, we will not be able to touch any kind of a live wires. We will not be able to touch it. Only places where they don't use the insulators, means on the wire, is the transmission lines. If you have seen transmission lines, to save money, so they put high towers so that no humans or will reach that particular point. So those will not be having insulator. They are stranded conductors with materials like aluminum they use. In our household, the kind of wires we use, they come with the coating, okay, upper plastic coating, and inside we will be having the copper. So that is how both are very, very important for the protection of the equipment as well as the humans.
Sir,
Huh.
our body also offers some resistance.
Yeah, it offers a resistance. That is why if you have seen, like if you touch small batteries, like dry batteries, 1.5 volt, and low voltages, if you touch, you really don't feel a shock, isn't it? But as the level of the voltage increases, that will become a very fatal. Right? If you touch, maybe sometimes accidentally you touch 240 volts, right? Accidentally, immediately your body retracts, okay. But if you come in hard contact, somebody gave a good example of water. So most of the accidents happen there. If there is a live wire which is fell in water, and you come in direct contact, there is no way easy way to retract, so your body will starts conducting. As the voltage level increases, the amount of current will increase, and the fatality will also increase. Sometimes if it is low voltage, maybe you will get little burn, and it will not be fatal. But as the voltage increases, yes, definitely our body offers resistance.
Thank you, sir.
Okay. The resistance is said to be 1 ohm if a potential difference of 1 volt across its end causes 1 ampere to flow through it. Okay. Uh, okay, circuit. Okay. If resistance is 1 ohm, I can call this resistance would be 1 ohm. If I apply a potential difference of 1 volt, means VAB is equal to 1 volt, and it makes 1 ampere of current to flow, then I would say this resistance as 1 ohm. Okay. And resistance of okay resistance of a particular substance, it depends on various factors. Do you know any of those factors? What does the resistance depends on? Resistance of
Temperature.
Length of
temperature,
the conductor.
Length of conductor.
length of
Area of
conductor,
cross section.
Material.
material.
Length of the
Yes,
nature
length
of
is
the material.
nature of the material. Anything else?
Area. Area of
Area,
the
area of
area of
cross
cross
section.
section.
Temperature.
Temp,
Density.
not really density. When we say material, it takes care of everything. But that is correct. Okay. So we told length, area, then temperature, somebody said, and the nature of the material. Okay. So length. As the length increases, what happens to resistance?
Increases.
Yeah. Because
Increase.
yes, correct. Let's say I have 1 meter of a conductor, and it has a, just assume that it has a resistance of 1 ohm. If I increase, if I take another 1 meter, if I make it as a 2 meter, definitely the amount of resistance, because we have more length, the resistance will increase. How about the area of cross section?
Decreases.
Resistance decreases as area increases. Anybody, can you tell me why that happens?
Inversely proportional.
Inversely proportional to
Firstly proportional.
Okay, inversely proportional. No, correct. So you can take that analogy, a simple analogy. Let us say you have a small road. When the road is small, the traffic would be more, isn't it? Like because the road is small, it offers more resistance to the flow of the vehicles. So whenever the road is small, the traffic would be more. When the road gets bigger, wider, okay, when road gets wider, there is a more space for the flow of the movement of the vehicles. Similar to that, when the cross section area, is bigger, there is a more space for the flow of the electrons. The electron collisions, relatively it will reduce when the area is more. So that is why when area is more, the resistance will drop. When the area of the cross section, is very small, like this, all the electrons are squeezed into a smaller space, though the chances of collisions are high, the resistance will increase. That is correct. So and for the substance, it is the property of the material. Because of its property, it will offer either high resistance or the less resistance. How about the temperature?
Directly proportional.
Directly proportional. As temperature increases,
Number of electrons.
yeah,
Number of electrons actually increases.
number of atoms excited will increase, the collisions will increase. Okay, so that is how the resistance will increase. There is free flow of electrons will not be possible. As the temperature increases, the atomic movement also increases, so the free flow of the electron will decrease. That is how the resistance will increase. That is correct. So resistance of a conductor is directly proportional to its length. As length increases, resistance increases. Inversely proportional to its area of cross section. As area of cross section increases, resistance decreases. As area of cross section decreases, resistance will increase. Depends on the nature of the material and depends on the temperature. As temperature increases, resistance will increases. So if you put these relations in as a formula, resistance is directly proportional to L divided by A, and if if you replace the proportionality sign with the equality, it will come with a constant rho. So R is equal to rho L divided by A, where rho is what? It is resistivity
Resistivity.
or specific resistance. Is it constant or it changes?
It changes, sir.
Constant.
Constant. It is constant for a given material. For a given material, resistivity or specific resistance will not change. Let us say copper has some specific resistance. For copper, it will remain same. So if you take aluminum, it might have a different specific resistance, but it would be constant. So specific resistance is constant, and the unit is ohm meter. So if you rewrite this, this will become rho is equal to R into A divided by L. R is ohm, A is m square divided by m, so it will become ohm meter. The unit of the specific resistance or resistivity is nothing but the ohm meter. Okay, next is the Ohm's law. Now we understood all the components, right? Different components of the electric circuit. Now we will study Ohm's law. And why we are studying Ohm's law and the Kirchhoff law? So that we can do the analysis of the circuit. Okay, so Ohm's law gives relation between some of these entities, and we will see that in the next session. If you have any questions, we can discuss about the questions for 2 minutes.